Hi guys, let's start the journey of differential equations today. So today I will be telling you what essentially is a differential equation. Now we're already very much familiar with the equations of this kind. You can have a quadratic equation like this, you can have a trigonometric equation like this, and you can have a simple linear equation like this. We are very much familiar about these equations, how to solve them, and whatever is working around these equations, we know very well about it. Now, if you see in some sort of equation, somewhere the derivatives coming into the picture. So for example, if I may give you x dy by dx plus y equals to 0. So now what is happening is that you have a product of x and dy by dx. dy by dx is the derivative, right? The moment you have a derivative, it could be just dy by dx, it could be d square y by dx square, it could be any level of derivative. Now, this is what will be known as a differential equation. This is just the beginning of the story. This is what is a differential equation. Now, what we have to do when we have a differential equation is another story altogether. So we will move on to that. But let's first of all understand, what are these differential equations of different type. So this is one thing that you need to know, that a differential equation is any equation which consists of derivatives, basically. Okay. An ordinary differential equation, it involves derivatives of the dependent variable with respect to only one independent variable. So for example, if you have an equation which consists of dy by dx, so y is the dependent variable and x is the independent variable. There's just one independent variable, right? If you have an equation which consists of d square y upon dx square, again the variable which is independent in nature is just x. So it's just one independent variable. For example, I've just given you an example here, twice of d square y upon dx square plus dy upon dx whole cube equals to 0. Now, what is happening here? You have cube of dy by dx, and you have second order derivative of y with respect to x. But clearly, there is no other independent variable apart from x. So x is your independent variable and y is your dependent variable. The moment you have just one independent variable, that is called an ordinary differential equations. This is an example of an ordinary differential equation wherein y is dependent and x is independent, just one independent variable. Comes to ordinary differential equations, there are two things or two words that you must know. The vocabulary is order. One is order. So let's understand what is order. Now, order, for example, let me just start with an example here. So suppose you have dy by dx equals to e to the power x, or you have d square y upon dx square plus y equals to 0. Or maybe you have d cube y upon dx cube plus x square d square y upon dx square whole cube equals to 0. Now, if the question is that what is the order of these differential equations? Order, you have to remember, is the highest derivative in the equation. So if we may talk about the first one, the highest derivative in this equation is of order 1. So you just have dy by dx. So the highest order is order 1. d2y upon dx square is the highest here. So the order here is 2. And here you can clearly see that you have d cube y upon dx cube. And then you have d2y upon dx square whole cube. So the derivative is d square y upon dx square, right? The highest one is 3. So 3 it becomes your order here. So highest derivative. That is what is order of any differential equation. There's another very interesting thing. So clearly here, as I mentioned, order, would be 1, 2, 3 respectively. And the reason is the highest derivative in the equation. First equation, the highest derivative was just dy by dx. Second, it was d2y upon dx squared. Third, it was d cube y upon dx cube. There's another important word out here, which is another important vocabulary for you, which is degree of a differential equation. Now, degree, the word degree, if you associate it with, generally we associate degree with polynomials. So here also, when your differential equation is like a polynomial, the degree is the highest degree of the polynomial, right? So let me again, pick up some examples maybe, and it could be clearer to us. So for degree, differential equation must be a polynomial equation. That's the first and foremost thing, as I told you. In terms of y dash, y double dash, when I say y dash, it basically means dy by dx. When I say y double dash, so this is for dy by dx. This is for d2y by dx squared. That is the second order derivative, then the third order derivative, and so on and so forth. Okay, and degree is when you have a differential equation in terms of a polynomial, then the degree of the polynomial. So the concept is related to that. So if I may give you an example here, d cube y upon dx cube plus 3 times d square y upon dx square whole square minus dy by dx plus y equals to 0. Pretty much like what do you say, a polynomial, like a polynomial, pretty much like a polynomial out here. Second one is a dy by dx whole square plus dy by dx minus sine square y equals to 0. And the third one is dy by dx plus cos of dy by dx equals to 0. My first question to you, or I want you to think, the third one that I've just given to you, dy by dx plus cos of dy by dx equals to 0. Does it look like a polynomial? Well, absolutely no. This doesn't look like a polynomial to me because you have cos dy by dx. So this doesn't look like a polynomial, right? So we will be moving on to degree, and degree is the highest power of the highest order derivative involved. So highest power of the highest order derivative involved. So in the first one, if you notice, what is the highest order of derivative involved? Highest order of derivative involved. The highest order of derivative involved is q, d cube by dx cube, right? That's the highest. d2y upon dx squared is not the highest. The highest is d cube y upon dx cube, right? So here, the power of this is just 1. This is the highest order of derivative that is involved in the equation, and the power of that is just 1. So that means degree, I will call that the degree is just 1. In the second one, the highest order of derivative is just dy by dx. So order of the highest order of derivative is just dy by dx. So dy by dx is the highest order derivative, and the highest power is 2. So the degree here becomes 2. And the third one, that's not a polynomial at all. So you cannot define degree out here, okay? So that's what degree is. Degree of a differential equation is the highest power of the highest order derivative involved in any differential equation. Now, I would also like you guys to find out the degree in the case of previous examples. So I had given you the example dy by dx equals to e to the power x. The highest order of derivative is dy by dx. So the order is 1 and the degree is also 1. Now d2y upon dx square plus y equals to 0. So order, because the highest order of derivative involved is the second order derivative, right? So 2 is the order, but the power of the highest order is just 1. So degree is 1. Similarly, d cube y upon dx square plus x square d2y upon dx square cube equals to 0. So order is clearly 3 because the highest order of derivative is 3, but the power of that is just 1. So it's going to be just 1. as the degree. Order is 3, but degree 1. And then, the next few ones I've already discussed with you guys. The next few ones. Now we can discuss the order also here. So the next example was d cube y upon dx square plus 3 d2y upon dx square square minus dy upon dx plus y equals to 0. So the order, here I've mentioned order and here I've mentioned degree. So order, the highest order of derivative is 3. So 3 is the order. But the power of that is just 1. So degree is 1. Similarly, you have dy by dx square plus dy by dx minus sine square y equals to 0. Now, order is 1, but the degree is 2 because dy by dx, it's first order derivative. So order is 1, but the power of that order is 2. So degree is 2. Dy by dx plus cos dy by dx is equal to 0. Now, the order is 1 because the highest derivative is dy by dx, but the degree is not defined because this is not a polynomial. So this is what I wanted to discuss in this lecture. What is order? What is a differential equation, number 1? What is order of a differential equation? And what is the degree of a differential equation?